Okay, the purpose of this video is to show you how to use StreamUX as an API on the StreamUX module. So first you want to download this package that you can get from our website, PK3210, and you want to extract that somewhere on your computer. So while that's doing it, I just want to show you I got my module hooked up here on the camera, and I've got the JTag is actually using Tag Connect, so you'll need one of these cables to use. This is on the mid module. The max module doesn't use the Tag Connect, but for now this is the mid. So you want to plug in your ST-Link in the JTag thing, and I'm powering it just through the UART cable, which comes with the development kit. You can plug that into USB, either with a phone charger or on your computer. Alright, so now that this is downloaded, I'll show you real quick. You want to open up CubeIDE, SDM CubeIDE. This can be downloaded from ST. I'm going to go to File, Open Projects from File System. I'm going to choose, go to where I've downloaded this. You want to go under Projects, and I'm using the mid, so I'm going to select mid, Application, and then select the CubeIDE folder. Select that, hit Finish, and it should pull the project in for the StreamUX mid. And I'll go over these at the end of the video. I'm just going to get it started for now. So first thing you want to do is select your configuration. I'm using a StreamUX 7. So I'm going to go to Build Configuration, Set Active, and it's already selected. So this is the StarTech 7 display is what's on it. So I'm going to select that. Then I can go ahead and build my project by hitting right click, build, and we'll let that run. Okay, no issues. And then you can go ahead, and since I've got the JTag or the single wire debug plugged up and it's powered, I'm going to go ahead and hit debug, and that brings up your launch configuration. You can use everything that's standard in here. You don't have to change anything, but I will say it does use the single wire debug just in case that's not selected automatically. So just hit OK, and that should start programming. And now you're ready to run. Before you run though, you need to be able to load the resources on there. This is the code. StreamUX resources are separate from the code. So I'm going to show you real quick how to do that. For the mid, I have several demos that you can use. The 7-inch screen has an 800 by 480, so I'm going to select that one. And I'm going to go under Graphics. And under Graphics, this is the StreamUX Builder project that has all of the resources in it. If you want, you can go in here and see how those are made, and you can generate the binaries from there, but these are already pre-generated in the zip, so you don't have to do all that. I'm just going to go load the binary. So I go into the .generated folder, select this, the UXB file, and I'm going to copy that to my USB drive, which I already have loaded. So if I go to the USB drive, you want to end the root, and it's probably better if it's the only file there. It doesn't have to be, but and then what you want to do is right click on the drive and click eject. And now you're ready to pull the USB drive, and I'm going to put the drive into the USB port of the StreamUX mid module. So now when I run, it's going to see that there's the resources there. I'm going to go ahead and hit run. It's going to say, hey, I found this USB or UXB file. So it's going to run through a resource check. While it's doing that, I'm going to go, I'm sorry, not a resource check. It's going to do the resource check, then it's going to load all the resources, and then you're going to be ready to run. You don't have to do this every time, you just have to do this the first time. So while that's running, I'm going to kind of go through the project real quick, kind of bottom to top. So the first thing you'll see here is the the IOC file, that's the CubeMX configuration. You can, I'll go ahead and load it. You can see my resources are updating. So everything's pre-configured here for how it is, but if you wanted to use some of the expansion IO, you can, and you would just configure it here. These are the linker files. I'm not going to keep going from the bottom to the top. So under this config folder, we have a hardware configuration. This is how the hardware is configured. It just kind of has which timers are used for each thing, which IO is used for each thing. You really don't want to change this unless you're doing something out of the ordinary. But it does have different display configurations at the bottom. And we're using this 7-inch display. But that's that. This is the output folder. This source folder contains all of the most of the source that you'll use with your project. So, and it's divided into several areas. The app folder contains this app.c and .h file. These are kind of where the app entry is. This is called from main.c, and this is called in the while loop from main.c. So this initializes everything. This is the running while loop that calls the StreamUX execute. And you want to call this as much as possible. This is just handles LEDs, the blinking and the communication. The communication LED blinks every time that it receives a command over serial interface. This is all the messaging for when StreamUX is used as a serial module. You don't necessarily need that if you're using it as an application, but it's in here anyway. This StreamUX app, this is what initializes StreamUX. It handles the USB and how to load resources and everything. This is just what kind of kicks off the StreamUX library. Kind of shows how all that works. This is also part of your using StreamUX as a serial display, but we're not doing that in this video. So this is just all the low-level drivers for everything. I won't go through those. This message folder, this is also for when StreamUX is used as a serial display, but we're not going to go through that. The storage folder contains all of this is what handles the resource loading from the USB. So kind of what's executing right now in the background. That's all right in here. StreamUX driver, these are drivers that are used directly by the StreamUX library. So this is the audio driver, does some I/O. This is where rendering happens, and this is what's using since we're on an ST processor, it's using the Chrome Art 2D or the DMA 2D accelerator. This is if you want to use some pins for timing on your scope. This is the actual screen driver that handles all the screen transitions, and this is settings is handles passing settings from StreamUX Builder to your module. There's some settings that you put into StreamUX Builder that can be loaded there. And this is all the touch handlers that we have. And currently we support resistive touch in 3 different cap touch families. This comes from the CubeMX. This is generated by that. This is the actual demo. So we're loading the 800 by 480 StreamUX resources in there now. This is, of course, this is the same folder that I just showed you that has all the builder project in it. We don't use it here. But this is all the source that shows in each individual screen and how to use the API to do what the screen magic is doing. This is generated by CubeMX. This is the FATFS, also generated by CubeMX. All of these are. This is the core, is also generated by CubeMX. Here's where your main.c file is. I'll just kind of show you this real quick. All it's doing is using this app.h file. So it initializes it here, and here's your while loop that's calling the run function. It's also doing the USB handling in the background. And the includes also is generated by CubeMX. So everything except for this, and this is generated by CubeMX. let's see. All right, so that timed out well. I'm gonna go ahead and pull this USB drive now that it's loaded and let that reboot. Okay, and now it's running. So this is the standard demo that you see on our website. But now you can go in here and pause, since make sure I had to go back to debug mode. But now I can pause it and step through code if I want. For instance, I could put a breakpoint here. And so if I wanted to see a demo screen, let me just do that real quick. So if I wanted to see how this color screen works, I'm going to put a breakpoint here. Let me hit run, go to the color screen, and there you go. So now you can step through code here and see how all these functions are working on the module. Thanks for watching.